I'm blue. Recording. Thank you, miss. So if I did this one in the same manner I did up here, so I have 1 yard is 3 feet, and 1 foot is 12 inches, right? So that would mean, bam, bam, 1 yard is 36 inches. I mean, that's another way to do that. That's the thing we did. I don't think we used it yesterday. I don't know if we did it yesterday, but we did that a while back. Same thing with the seconds. You guys see that? You can combine multiple conversion factors. And we did it. We just didn't do it like looking like this. We just didn't do it like this.
Yes.
Okay. All right, I'm going to clear all that. Anybody out there, you guys have any questions? I do want to talk a little bit about the glacier one more time.
Okay.
Does anyone else have any questions from anything?
I kind of had a brain fart on scientific notation.
Okay.
My answer on the calculator.
Where are we at?
On number 7, what you were just on page.
Here, this one? The one about the gallons and stuff?
No, 20 homework, page number 7 and 2.4.
Okay, let me see.
Page
Oh, yeah.
206.
That's going to be insane. Your answer here is going to be kind of silly. But so, all right. Without telling me the exact answer, what kind of answer did you get? Was it really tiny or really big?
Big.
Big. Okay.
So if I got 7.53218 minus 6, would I just write the 7 point whatever times?
Wait.
Just
Let
how
me
to
catch
set
up. Let me catch up to you. So when you did it in the calculator, you got 7 points, blah, 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 E negative 6.
Correct.
So that's already scientific notation. E means times 10 to the.
Oh, okay. And then so I
That's
just
nice. I mean, that's a
round off
given
the
right
first
there.
numbers. I mean,
What's that?
do I just round off the first number? So if it's 7.34 and a whole bunch of numbers, do I just write 7.34 times 10 to the negative 6? Or do I write all the numbers?
Not all the numbers. I won't see all that. And number 7 is a throwaway problem anyway, because we're not going to use those units. Anyway.
I've changed the units. I don't know if it's right, but I changed them from 2 milliliters so it can cancel.
I mean, it sounds right. I mean, the glacier is not moving fast, right? We don't talk about glaciers just suddenly coming up on a town unaware. You got run over by a glacier. This one doesn't happen. Right? So I knew this is supposed to be small. So when you said big, I got worried. But the negative power means it's really tiny.
Okay.
All right. I like it. So one nice thing about the TI calculator and scientific calculators is they'll give you the weird numbers in scientific notation already, which is always, appreciated. Makes that question easy. Anything else, guys, from homework stuff? And, if you have something else, Nikisha, you can ask because nobody else is asking anything.
Professor, could you please explain number 8, please?
All right, here we go. This is the one I was going to talk about. So let's see if I can do this bad boy. There we go. So, all right, to kind of talk about this, I'm going to make up a couple of things that are not true. All right, I'm going to also, I don't necessarily need to hear everything happening out there. Why am I not able to mute this person? All right, oh well. Okay, guys, so in number 6, you figure out a speed, right? You figure out how fast it's moving inches per hour.
Yes.
Yes. And then number 7 is sort of a throwaway question. Number 7, I'm not going to use that answer. It's just talking about how silly that would be to do that. That's all number 7 is there for. And number 8 gives me a distance to go in, a distance to travel. So this is not the right stuff. So let me pretend like my answer to number 6 was 4.12. I don't want the right answer.
Okay.
I'm not going to do your work for you. So let's say it's 4.12 inches per hour, just to make something up. All right. Oh, there's me. All right. Now, that's one thing I know. I also know, I know I want to go 100 yards. Can everybody mute yourselves? I seem to have less power than I should, which is troubling me. Everybody here, wait a minute. Yes, I have power now. All right, sorry. Let me share my screen again. All right, sorry. So I got to make this up again. I think it was, so yesterday I talked about the idea of distance equals rate times time, which is one way to do this. Another way to do this is, what's wrong with the distance I have to go and the speed that I know? Why are they not jiving? Why are they not working together? What's wrong?
We need to divide it by something to.
You're telling me too much math, which is kind of funny in a math class, but that's the way it is sometimes. What's wrong with the distance I want to go and the speed that I know? Why are they not hooking up correctly?
Because
They are not the same.
units.
Yeah, the units are wrong. This is inches, this is yards. So if I could change this to inches, that's one thing. Notice something else. This is a conversion in its own right. This is a conversion from inches to hours. I want you guys to understand. Does that conversion work anywhere else except for this glacier? No. Right? That'll be really weird if you're like, well, that moved 4 inches, and somebody else is like, well, that was an hour. What the shit? No. 4 inches is not equal to an hour in everyday life. But do you agree with me for this glacier, if it's moved this far, it's been an hour? And again, just remind you guys, this is not the right answer for number 6.
Yes.
So if I know I want to go, let's pretend I want to go, you could do it, Jeff, 7 yards. How far is that? So the first thing I've got to do is I want to make them the same units. Do you guys remember the shortcut we made up from yards to inches?
Yes.
What is that?
1 yard, 36 inches.
I like it, right? Yard, 3 feet. Each foot is 12 inches. 3 times 12, 36. Bam.
Kill the yard.
Huh? So that goes away. So I believe that's 252 inches. You guys can. Now, to be honest, I'm actually going to take that away. I want to show you something. So if I wanted to do that right there, I could. But I want you guys to I want you to realize something. I can keep going. Can I convert inches to hours? In general, no, but can I do it in this problem? Right? Where would I put inches? Where would I put inches so it would cancel?
Bottom.
The bottom.
And now I fill in what's true for this problem, 4.12 inches in 1 hour. And now I'm going to end up with hours, which is what they want to know. How long it would take. So any ratio, any rate is actually a conversion in its own right. So if I get paid $8 an hour, that is a conversion. That's a conversion between hours and money, right? If I'm going so many inches an hour, that's a conversion between inches and hours. So I can use it. I can use it the same way I would anything. So now you just use the numbers that they give you and the numbers that you get from number 6, and you do the same idea. You start with 100 yards, you convert yards to inches, and then you convert inches to hours with what you know from number 6. All right. Yesterday I talked about the distance equals rate times time, and it would tell you to take distance divided by rate, which is exactly what we end up doing here anyway, right? So it's actually making it more just converting instead of knowing a formula.
Thank you, Professor.
You're welcome. All right. Anything else, guys, from homework stuff?
No, I just had to agree with Nikisha about how it's worded. Sometimes it's, you know what I mean? It's,
I know what you mean.
wording can throw you completely off.
Yep. And that's true in real life too, man.
Yes.
Right. When we do our taxes and there's updates and you read through something, you got to read it 5 times just to figure out if what the hell. Yeah. So, I mean, why not? That's some practice for that shit too. It's going to happen all the time. With that said, if there's ever a question you don't know what they want, just ask me. All right. So you guys sure there's no more questions? Is that it? You guys? Yes. Yes.
Another question. It's another simple question, but if an answer when you put it in a calculator is 0.72, and they want it in miles per hour, do I convert it and make it 72?
Now, wait. Stop. You should already know the units, which are independent from the number.
Okay. So when I put in a calculator, I'm putting those units in already.
Well, all right. You're kind of confusing making something into a percentage versus, so when you do a problem using conversions like we do, the units are figured out. In fact, that's the first thing we figure out are the units. And then we just do division or multiplication based on where our numbers are. So the number doesn't tell me what the units are, right? So if you set stuff up, blah, 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 so what's left alive is miles and hours, and all the other units canceled, well then whatever the shit the numbers come out to be when you multiply and divide them, that is miles per hour. Because the units are already figured out. So don't look at a number like this and figure, oh, I got to change. No. That is what that is.
Okay.
And the units are just whatever that's left alive. Does that make sense? So it's.
Yes.
All right.
Yeah.
Yes.
When you're talking about units and it's giving us how to calculate
Yes.
find the speed in miles per hour. So the trouble that I have on my end, speaking on my behalf, it would be finding out what unit goes on top, what unit goes on the bottom. I have trouble reading the math problem in that way.
No. So all right. So for number 7, so number 6, you're going to find inches per hour, right?
Okay.
Okay. So let me make something up for number 7. So I'm not doing exactly here.
All right.
So let's say I got 8 inches per hour. And now they want me to make it into miles per hour. So now let me do on the side. What do I always do before I start trying to make my grid? I figure out what path I'm going to take. How can I go from inches to miles?
But where does it even say inches in the question? It says find the speed in miles per hour.
Wait. I know. But where's it coming from? Remember, these problems almost always build on each other. So number 6, you're going to figure out a speed in inches per hour. Number 7 says, find that speed in miles per hour instead.
Okay.
So they could have said, convert the speed you found to miles per hour. And I think that's to Nikisha and Linnell's point. That would have been a little more direct way to say it. And like I said, I don't care. You're going to have to
Right.
deal with the weird way people word everything in the whole world. So
Yeah.
they decided to word it like this. Does that make
Okay.
sense?
Yes.
So they want you to find miles per hour. So of course you're not going to start with miles per hour, or else you're done before the question was asked, right? So you start with inches per hour.
Right.
Yes. And so so coming back to this, because I'm almost certain that somebody out there needs help with this and isn't saying a damn thing. So if I have inches per hour and I want to go to miles per hour, so I need to make inches to miles. The hours are already good to go. Yay, I don't have to worry about them. I don't want to touch them. How do I go from inches to miles?
Inches, feet to miles.
Exactly. And again, remember that page 192 is important. You want to be able to scroll back to that sucker whenever you need to, or print out a copy of it or something. So I can go so I put my 8 inches per hour. I want to kill inches and make it become feet. So where am I going to put inches?
You're gonna place it on the bottom, on the denominator, right? That's what.
I like it. Bam, bam. I'll accept bottom instead of denominator. It's fine.
Oh, what? Okay, bottom. Is that right though? The numerator's on top and the denominator.
Yeah, totally. And then I want to go from feet to miles. So where am I going to put feet? Top or bottom? Numerator or denominator? Denominator.
All right.
Which one? Where am I going to put feet?
You're gonna move it.
No, I'm not going to move it
It's
anywhere.
on
Where am I
top.
gonna- It is on top. So where am I going to put feet here so I kill it?
On the bottom right.
Yes. So now feet are gone. So what am I going to end up with? Miles per hour. So that, to me, I can sense that some of you guys still don't like this at all, but this shit is so cool. It's barely math. You put inches there and you want to go to feet, and then you put feet there. So you kill, it's no longer, inches are gone, feet are gone. So what's left? Miles per hour. Oh, sweet. That's what they want. And then you fill in the numbers. Now the math kind of comes in, right? So there's 12 inches in a foot. That's crazy. And then how many feet in a mile?
I think it's
52.
5280.
There you go. Okay. And now you just do 8 divided by 12 divided by 5280. And you get that crazy small answer that Nikisha got. Well, sorry, that's not the right number, right? Be careful. Be really careful. I'm not doing your work for you, remember? That's not the right answer. It's whatever you got in number 6. It'll be something inches per hour. That's what you want to put there, right? So I'm not doing your problem for you, but you basically do the exact same thing I did. So this step, this step right here is the one that so many people skip, but then they make really silly mistakes. You got to think first, how am I going to get from here to where I want to be? You got to plan that out ahead of time. All right.
Excuse me, but
Yes.
sometimes I use like different like conversion to get to what I want, like by looking at the table, you know, of the conversions. Is that fine? Like at least the result is as I want it.
Like, what's an example? Do you use a different?
Like, let's say I'm using for number 7, I use different methods, like not just inches, and I use other things.
Well, you have to use inches because that's where you start. And then you went from inches to what?
I did it with a millimeter.
Oh,
I didn't do it with it. Yeah.
I did it
So let me
that
tell
way
you this.
too.
Let me tell you this. You do not want to do that. You don't want to change systems unless you have to. So if they ask me to find the speed in centimeters per hour, then I have to change systems, so I will. Because the change from one system to the other is really, really gross. and the decimals they give me, the 2.54, for example, isn't right. It's 2.54, blah, 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 blah. There's more to it than that. So the conversions are gross. You should end up with close to the same answer, but it's going to be off a little bit.
Uh-huh.
And I don't know if you did it. Did you do it as quickly as we did this? Well, so if you go from inch to
It
millimeter.
comes, because I did it like, the 1 meter, it's 1,000 millimeter. Because I
Sure.
looked at that table.
Sure. And then you have to go, and then you have to go from
Millimeter
there
and fit
kilometer,
with
and
a
then
foot.
from there to miles, I guess, right?
Yes.
Okay.
Yeah.
So there's a little bit longer here. So there's
Yeah,
two reasons.
It's not too long. Mm-hmm.
Two reasons you don't want to do that. It's going to be longer almost all the time. And it's gross going from one system to the other because the conversions are worse.
But it's not too wrong. Like it's not, but
No,
that
it's
maybe
not, not wrong. No, you're fine. If you do it that way, because that's the way you think about it, do it.
Yeah.
It's better than nothing, and it's you get almost the same answer.
Yeah. And
Okay.
also I want to ask you about the question number 8. So at the end, we're gonna end up with the hours. The length that it takes, it's an hour.
You have to end up with hours, yeah.
Okay.
Yeah. So you have to end up with time. That's right. Okay. Anything else from homework, guys? I'm going to clear all that mess there. Okay.
I wanted to see if we could go over the roster method.
Oh, that's just, all right. So that's just making a little set of answers. So if I said, for example, all right, here's some nice big white space. I like it. So if I was like the roster method, I love this. They make it sound so official. Roster method. It's 1-0 from a rooster. So if I said, can you use the roster method to tell me at most 5 people can be in the store? Because of COVID, right? So can you list out how many people can be in the store?
Numbers 1 through 5.
Well, even more than that, to be honest. Or 0.
Zero.
Yeah, when it's shut down, 0 is the only acceptable number, right? You don't want anybody in the damn store. Okay. Is that cool? I mean, that's all that means. That's all a roster method means. So, if they said, you got 15 people and you want to choose at least 9 people, well, how many people could you choose then? So I got 15 people standing out there. I need to choose at least 9. How many people could I choose?
0
through
The first 9.
10, 11, 12, 13, 14, 15.
Yeah, so what does at least mean? Is 8 at least 9? No.
Oh, okay.
You're thinking 8 is less than 9. Sure, that's true. But what is at least? If you have to be at least 21
So
to
9,
drink
10.
legally, you can't say, well, I'm 20, so that works. Yay, all those old people can't drink. Ha, ha, ha. No. What are you talking about? I can drink, thank God. Gets me through things like debates and shit. So at least means that or more.
Right.
So it'd be like, I think somebody said just a minute ago, it'd be blah, 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 blah. Okay, that's the roster method. Just list all the possible numbers. So at least means that or more. At most means up to that. So if you can be at most 12 to eat off the kids' menu at Denny's, you just turned 13, too bad for you. You can't eat off the kids' menu. Nah. Happy birthday, right? Is that all right? So those two give people a lot of trouble. I understand. But to me, I always remember at most is related to an elevator. You can have at most 6 people on the elevator. So 7 ain't going to cut it, right? And at least is you have to be at least this tall to ride the ride. So if you're shorter than that, you ain't gonna make it in. So those two examples would keep that straight. Maybe. Does that help? Maybe. Is that all right? So that's what the roster method means. That's all it means. It makes it sound like it's some crazy thing, but it's just listing all the possibilities. All right, I'm going to assume that's okay because I'm not getting anything back. Okay. Anything else before we get back in the? Oh shit! I didn't mean to clear it that quick. Sorry.
Yeah. I had to get to the mute. Don't you have approximately, what was that? Another sign?
Yeah, approximately. So if I said, so that's related to the estimation that we can do.
Right.
So if I said, what is 82 minus 11.84? That's approximately what?
$90.
Oh no, I'm subtracting something from 82.
Oh yeah.
So what?
Oh,
What?
So I go up to on that. So 80 and 12. So
Well,
92. I mean,
no,
80,
you're still adding. Okay, guys. What's a nice number to make that? Because it would go with
12.
82.
12.
82 minus 12. So I can say this is approximately 12. So 82 minus this is approximately 70.
Oh, okay.
All right.
You don't round both numbers.
Not necessarily, especially when one of them is so close to something that would work really well with that dude, right?
Oh, okay. I remember you saying one up, one down. So
I'm with you, but that was so close to 12. Is this too high or too low?
Low.
Yeah, because I subtracted a little more than I was supposed to. So of course it's going to be a low estimate. I like it.
What page, Jeff? What page is this question in?
It's on whatever page I'm on because I totally made this question up just now.
Oh, well, there it is. 209.
Okay. But it was an example of
Next.
this symbol. It just means approximately, right? I like it.
I mean,
But to Linnell's point, to Linnell's point, if I had something like 573 minus 281, if I wanted to do this, I would make this go up to 6 and this go up to 3. So this would be approximately 3. Is that all right? Does that make sense?
yes, it's
Just go
usually
up.
when it's both decimals.
Yeah.
That's what you're saying, Jeff?
Yeah. So this leads to a trick that I think I might have shown you before, but let me see if you guys are with this. What really sucks is that when I have to do something like 1,000 minus 817, if I have to do that by hand, will that not suck? You're going to have to do a ton of freaking borrowing and, oh shit, whatever. So what I can do you see how when I'm subtracting, what's 6 minus 3? It's 3. Well, if I make that go up 1 and that go up 1, what's 7 minus 4? It's still 3. So if I'm subtracting and I make both the numbers increase or decrease by the same amount, the distance they're apart stays the same. It's still 3, right? If I made it go down to 5 minus 2, isn't that still 3? So watch what that leads to. This would so suck, right? If I have to do this by hand. Oh, crap, I got to make that, and then I got to make that. Oh, screw that shit. Get out of here. Let me take this down by 1. That becomes 999. And let me make this go down by 1. 816. Is that easier to do? Well, shit, yeah. And you get the exact same answer. Of course you do. It's the same thing as 6 minus 3 is the same as 5 minus 2. It's the same idea, and that's a really useful little trick if you have a bunch of those to do by hand. Maybe. Maybe. I get a little concerned when I get no reaction at all.
Well, I was on mute. I was talking. I said good idea, but
All right, all right, all right. Now, when I am adding, it's sort of the same thing I got to do when I'm multiplying. When I'm adding, I really do want to make things. If I make one go up, I want something else to go down. So if I had 698 plus 4107, I can approximate this by this going up and this going down. And that makes sense. If I'm adding two things, if one of them goes up a little bit, the other one's got to go down a little bit, so they add to make the same thing still, roughly. But like we talked about, I mean, estimation doesn't have like real hard set rules. These are sort of rules to keep the estimation close. But if I was adding, all right.
You're talking for question 4 on page
I am
209.
just talking. I'm just
You're
talking.
just talking.
Yep. Again, there are two separate things in a math class. There's ideas, and then there's things you got to do that relate to those ideas. So right now, I'm just talking about an idea. Yeah.
Okay.
I want you guys to realize if I had to add these up, crappity do that. I would make both of them go up, wouldn't I? Because they're so close. If I wanted to approximate this, what do I approximate this to be?
13,
13. And what do I approximate this to be?
14.
14.
14. So I get 27. Is that too high or too low?
Going to be too high.
Too high. So it's an overestimate because I made both of those go up. So of course the answer is an overestimate. But that's fine. Why wouldn't I do that? That's easier to make them both go up. And then I just realized that's a little bit bigger than it's supposed to be, because it kind of broke that little bit of a rule. But estimation is not supposed to really have hard set rules. It has some suggestions. If you make them both, if one goes up and the other one goes down, it makes the estimation better. But if it's easier not to do that, do it. That's the whole point of estimation, is to get a rough answer, right? But they will ask you sometimes if it's an over or an underestimate.
Oh, okay.
All right. But most of the problems you have to work on are not going to be as computational. You got a couple of things where you got to add a bunch of stuff, like going to the grocery store or something, I think is one problem. But then you have a lot of visual estimations too, which shouldn't be too crazy. Estimating something on a graph. Or even there's a problem, let's do this one. Let me see, I'm going to clear all this stuff away. Is that all right? It's going away. Stuff. Okay. I want to do, where am I at? Okay. What page was this again? I'm just going to take a guess. Let's see. Where am I? Where am I? Am I in a section still? Yes. All right. Maybe I should look up the page. I want to do a problem out of the chapter review for this. There we go. Page 276. That was better, Jeff. Bam. So this is page 276, and it's got this map up here, and they want you to estimate the distance from St. Louis to New York. So there's St. Louis. There you are. And there's New York. So how am I going to estimate that distance? What's on that map that I got to know, or else I can't do this?
Key, the scale key.
Yeah. Now, what methods could you use to estimate how far those are apart?
Can you use a ruler?
Yeah, you could use a ruler, or you could even just use like a pen cap, right? So you can't see what I'm about to do, but my pen cap is actually just a little bit over the 200 miles. And then I can just lay the pen cap and count how many pen caps it takes to get to New York. And I know that's going to be an overestimate. You guys with me? Or you can use your thumb or a finger or a piece of paper or a ruler if you happen to have a ruler laid around, right? You guys semi with me? Or you could even try to eyeball it, but that's going to be the worst if you try to eyeball it, but it's still an estimation, right? If you try to eyeball this sucker and say, okay, that's about, looks to be about one of them, and that looks to be about maybe another one, and that looks to be about maybe another one, and that looks to be about, so that's going to be a really rough estimation, but it's going to be relatively close, right? Maybe you guys all right? I mean, I'm certain that somebody out there has done this. Maybe not as much as we used to when maps used to live in books. We used to live in these. We'd have a big thing of maps when I went across country back in '97. Big old thing of maps on for every state. I was driving everywhere and I was looking at my map because that's before we had, entire computer in our pocket. Whatever, Jeff. I was paying like $1 a gallon of gas. Yeah. All right. All right. So part of the problems you're going to see are going to be computational, and part of them are going to be visual, like this one. Okay.
So, Jeff, how would you calculate that then? Are you just telling us to give you like an estimate based off
No. I discussed several ways. So you could either use like my pen cap, right? My pen cap. When I put it up on the screen, it's actually it's a little bit longer than the 200 miles. So then I could just lay the pen cap from St. Louis and count how many it takes to New York. Does that make sense?
Yes.
So I count 1, 2, 3, almost 4. So 3 times 200, because each pen cap was about 200 is 600, and 4 times 200 is 800. So I'd say about 700 miles.
Okay.
That's probably an overestimate, yeah. Or you just eyeball it like I started doing.
Well, you're probably going to have to correct me on the homework, and we're probably going to go over it one more time before office hours. So,
Okay, sure.
thank you,
okay.
Jeff, though. I appreciate it.
Oh, yeah.
All right.
Let's see, where was I? Yeah, here we go. Sweet. All right, so if there's no other questions, we're going to get a little bit into the next stuff again. This is, well, we already did this, though. This is what we were just doing. There we go. So this is the one about estimation.
I have a question about one of the homework number 7 on page 225. If you could just explain to me like what the question is asking, because with the chart and the 100,000 citizens,
that is what this tells you, right? If you read this, it tells you the violent crimes per 100,000 citizens. So there's no work to be done with this because that's what this tells you.
Oh, okay.
So like Dallas, I would estimate had about maybe 600.
Okay.
6, 7, 8, maybe a little less than 600. 600 violent crimes per 100,000 citizens. So that's not a mathematical thing. That's just what this chart tells me.
Oh, okay.
And of course, you're always going to do that because if you just focus on, California has the most inmates of any state. I think it does. Right? And why is that fine? Why does that not mean we're all criminals in California? Because we also have the most.
Well, wouldn't you call California like a police state? They enforce every.
Let's understand the point here. California has the most inmates, which is fine because California also has the most
immigrants.
People.
Oh my goodness! Let's not.
Okay.
The laws are really strict.
People.
Well, if you do the statistics.
Stop. Because we have the most people. So we always want to. So the whole thing with coronavirus. Let's really get into some controversy. When President Trump, for example, says that we do the most testing, no, we don't. Per capita, we don't. We're not. I think we're 18th in the world. We are not number 1. That's bullshit. So. Of course we do a lot of tests because we have a lot of people. We don't do enough testing. I don't care what anybody says, right? So if you don't count how many people are there in the first place, you can't just say, well, that place is worse because it has more of this. Well, it's got more people. It's going to have more everything, right? So you want to do it. So per 100,000 people makes sense. Now I can compare different places on an even playing field. Does that make sense? So it's kind of like a percentage, but instead of being out of 100, it's out of 100,000. Okay, maybe. You guys have ever heard the phrase per capita? Yeah, and some politicians don't understand it, or they only use it sometimes. You got to pay attention. And that's the one that makes it fair to compare. Per capita means per citizen, per population somehow. So this is per 100,000 citizens. This is a fair comparison then. Okay. Because does Las Vegas and Miami, do they have the same number of people as Detroit does? Or Cleveland, for that matter? Probably not, right? So, but if I do it per 100,000 citizens, now I can compare them. Now it makes sense to compare them. All right, that's enough of that. Cool. I think I answered your question, right, Nikisha? You were worried about how to deal with this, and it's not something to deal with. It's just what this thing tells you. Yeah.
Yes.
Okay. All right. Anything else before I get back into new stuff? Okay. Let me see actually if I want to do. I don't think I do. No. Okay. So I want to look ahead a little bit. Where we're about to go. So here's a little, we're traveling through the homework. What we're about to get into is something called relative change. And this is huge too. This is so misused by politicians because they know a lot of Americans don't understand it. So they misuse this thing like crazy. So let me ask you this. Let me see. If one person's salary went up, let me do this on the board. I'm tired of doing this virtually. Everything's virtual, Jeff. I know. If see what we got. Let's see. We got Tom and Betty, right?
And
Tom,
Jeff,
yo, what's up?
one question. So if ideally somebody can calculate their own financial, like they can calculate like more than a year or two, I'm saying like at least up to, if they're planning on a long-term, like a short-term but long-term goal, like financially, they can calculate. How would you calculate if you have credit card debt with your income? You can calculate that with your bills and graph that and see.
All right, wait. There's so many questions there, and it's not really related to what we're talking about.
Okay.
Obviously, you can. You have a lot of different ways you're discussing right there with how to look at things. So, right? I mean, and I'm not going to get too deep into that because it's not really related directly to what we're going to talk about. I might bring some of that in a minute to what we're talking about. Yeah, so that would be a question I could answer for you some other time, but not right now in the middle of a different.
Sounds good.
Yeah. Okay.
Excuse me.
That's all right. So let's say that Tom has his salary increase by 10%, and Betty has her salary increase by 5%. What's that all about? Who is now making more money than the other person?
Well, it depends on, are they making the same amount starting off?
I love it. There you go. That's the point.
The starting amount, yeah.
I love it. Okay, so everybody gets that basic idea. I can't just say, well, that's bigger than that, so I know who's making more money. I got to know where they started. Because just because that's bigger than that, if Betty started off at, let's say she's making, what do you got, Jeff? I don't know. Let's say she's making $1,000 a month, or Betty. And let's say Tom is actually only making $800 a month, right? You guys with me? Does Tom catch up to Betty now? Well, now I can calculate it because I have an amount that it's based on. So it's the percentage change is relative to where it started, right? That's the point. I love that a few of you guys said, well, he didn't give us enough information. That was the point. I love it. So just to do this problem real quick, this isn't necessarily what you're going to be doing in the section, but does somebody know what 10% of 800 is? Quick.
80.
There you go. Because to do 10% of anything, it's just 1/10 of that thing. You move the decimal back. So that's $80 more. So now Tom's making $880. Betty, what's 5% of 1,000? Well, it's half of 10%, right? 10% of 1,000 is 100, and half of that is, what's up?
50.
Yeah, 10% of 1,000 is 100, and then 5% would be half of that. Cool. Just to give you a way to do that real quick without having to do it in the calculator. So now Betty is making $1,050 a month. So Tom did not catch up to Betty, even though he had a larger increase. Okay, so the point I wanted to make with that example was a percentage by itself doesn't mean anything. It's got to be of something. That's what gives it meaning. One real quick thing. Why not continue talking about COVID a little bit? I'm going to erase all this. Does anyone still need something there? This is, okay. Something that really pisses me off is, and you know, I'm kind of done walking carefully with my opinions about things nowadays. Just screw it. I'm seeing way too many people say, somebody posted this the other day that stop shutting the whole country down when 99.98% of some age group survives COVID. Let me stop for a minute. So when you look at the number, if you don't understand shit, like the person that posted this, you're going to think that, well, holy shit, why are we shut down for that? But how many people are in this group? So if this group has 80 million people in it, just go with me for a minute. So this is the same example what I just did. Without knowing the base, without knowing the amount that the percentage is building off of, I don't know what it means. It just, to the average person, they go, well, that's almost 100% survival rate. Who gives a shit? Open everything, right? And this is for very young people, by the way. For older people above 70, it's like a 95% survival rate. So 5% of them are going to die if you just open everything up. I'm sorry. I don't care what you think. So what percentage, stay with me for a second, what percentage would not survive? Give you guys a little bit freaky number. Say again?
0.02.
0.02%, right? So what is 0.02% of 80 million? Well, how do you change 0.02% to a decimal? It's the same as always. I've got to move it. Now be careful, don't let your brain go that way because it's a percentage, it's got to go that way. So we're going to add a couple zeros on, right? So what is 0.0002 times 80 million?
16,000.
16,000? Let me see. 1, 2, 3, 4. 1, 2, 3, 4. Yeah, okay, I like it. So that's 16,000 people. This is actually 16,000 kids. I can't remember the age group exactly, but it's like teens or something. So when they posted this, I said, okay, so you're okay with 16,000 kids dying, and above 70, it would actually be 2 million people. 2 million people would die. Anyways, I'm sorry I'm making this all about COVID, but and that should not translate to political, but unfortunately that's where we are. But
But I want to go to a restaurant.
Say again?
I want to go to a restaurant though.
All right, thank you for that. Yeah, that's the counter argument to that. It's like, well, all those people, I want to eat out, so they're going to die someday anyway. That's the argument. I love it. I love it. It's amazing, the compassion of some people. So the point is,
some restaurants.
Say again, sorry.
You can eat outside at some restaurants. There's
I'm cool with that. Don't get me wrong. I'm fine with outside, distanced. Unfortunately, people just can't handle that, especially Americans. They can't quite do things right.
It's my constitutional right to do what I want.
There you go. Yeah. I'm watching too many YouTube videos about Karens and Kevins or whatever the hell the male equivalent is. Let me get back to my point. Sorry, that's my fault for taking us down a road. When people say percentage, like, yes.
Jeff.
Yes.
Hey, I know that I butt in with my questions, but how would you stop that? How would you find a solution? You already know the problem. There's a lot of people walking out there that.
Right now, I don't care. I can't. There's the solution is to be in a different country in the first place, because other countries seem to be able to do the right thing. But let's get back to my point. When people see this kind of percentage, they automatically assume it means something. It means, oh, everybody survives. But that's 16,000 kids. 95% survival rate would be 2 million people 70 and above would just die, right? All right. Sorry. I should not have picked something like that.
Don't you think like placing some type of law that gives the people that are causing a bigger epidemic some type of ticket for being so careless and not mindful about
Some places have done that. Some places have started giving fines out for people that aren't wearing masks in certain situations. I think that should be more widespread. I agree with you. This is not the time to discuss it, though.
Okay, all right.
So here's where we're headed. So let me start with something that might seem old and not related, but I don't care. If I have 80 people in a room and 37 of them are men, what percentage of the people in the room are men? This is the kind of problem we should be able to
I'm not being facetious, but assuming they're all men and women.
Yes, good point. I should have picked something else. We're assuming that they all identify strictly as a man or a woman. Just coincidentally in this room. No, it's a good point. I have to be more careful. So everybody in this room identifies strictly as a man or a woman, and 37 of them are identify as men. In fact, to be honest, that doesn't matter. 37 identify as men. So what percentage of the room identifies as a man? There, that covers everybody.
Oh yeah, sorry, you're right.
No, you're good. I didn't even think about it from the beginning.
46.
About 42.
So take me through how you get to the answer. What do you set up?
Divide 37 by 80.
Yeah. So it's in relation to the total, right? And then whatever that is, it's roughly 45. Yeah. What'd somebody say? It's roughly 45%. It's like 46%.
46, 25. Yeah.
4625.
Yeah.
All right. I'll go with
But
it.
can't you also round the 37 to a 40?
No, it's way too big of a step up.
Oh, okay.
Do you see how that's 4 percentage points higher than what the answer actually is? So don't bring estimation in unless they ask you to. Now, There's nothing wrong. Now, here's where estimation belongs in all of mathematics. I put this in the calculator, I get this. Is that about what I expect? Well, if I round that to 40, I expect about half. That's a little less than half. It makes sense. Do you guys, that's where estimation comes in everyday life in any math course, right? How do you estimate that your answer makes sense? That is one, make that 40, it should be about 50%, a little less because I made that go up to 40. Hey, it's a little less than 50%, that makes sense. So if I got 4%, I must have moved my decimal wrong or something because that's way off from what I estimated it to be. I like it. But don't estimate to get the answer unless the question asks you to.
That makes sense. Just use it to double check.
Yeah. That's actually, I'm kind of happy you said that because that's one of the points for discussing how to estimate is so that you know how to tell an answer you get makes sense. So it should be around 50%. It was. Yay. So if I got 90%, I did something really wrong. All right, now, let me ask you this. We're actually going to do this a little bit in reverse, but if I have a $20 shirt I'm selling and I mark it up by 5%, what will the new sell price be? So this is actually an old problem. We've done this kind of problem before. So I'm going to mark it up.
$21?
Yeah. So how would you do this? You could do it in steps if you forgot the shortcut. So I need to do 5% of 20. So 5% of the original. Let me stop for a minute. I mean, this is nothing new. We've talked about this kind of problem before. But now we're going to do it kind of in reverse here in a minute. So 5% of 20 comes out to be $1. So the new sale price will be 20 plus 1, 21. It's crazy. So I'm making a whole dollar profit. Good job, Jeff. I know business. Okay. So now, what does that relate to what we're actually going to do? What if I had a shirt that was originally $30 and now it is $45? What was the markup? And let me say this. I'm going to say this in a different way. This is the new terminology for the section. What is the relative change in price? That's the more technical way to say this. The relative change in price. Because you know what the change in price is, right? They might even say, no, I can't remember if they say, there it is. Yes, they do. Thank God. Just want to make sure we're using the same words the book does. Is everybody with this so far? So this is the same problem as that. It's just that I don't know what the markup was, but I do know what the end price was. How the hell am I going to figure this out? Well, do you know what was the change in price? How much did the price change?
$15.
And how big is that related to where it started? So what percentage is this?
50%.
Yeah, so the second step would be, so another word for relative change is percent change. It's going to be 15 out of where it started, not 15 out of 45. That doesn't make sense. 15 divided by where I started, because how did I figure out the sale price? I did 5% of the original price. It's based on where I started. So this, of course, is 50%. So that's somebody who really knows business, not me going up by $1. They went up by 50%. Now they're going to make some money if anybody comes to their store. I don't know.
So when it asks for relative change in anything, it's asking for a percent?
Yes, I love it. So relative change is another name for percent change. There's actually something that's called Did we talk about relative frequency? Maybe not.
I don't think so.
No, I don't think so either. We did talk about frequency. Remember making frequency tables? Relative frequency would have been making those into percentages out of the whole. So the word relative very often means some kind of a percentage. Not always, but often enough. So let me give you an official formula, which we didn't really even need here, but I just want to give it to you because some people feel better with the formula. So the idea of relative change, that equals the original, oh, I'm sorry. How do I want to say this? I want to say this the same words they got. Yeah. The new value minus the original divided by the original. Which is what we did here, right? That we did the new value minus the original divided by the original. That's exactly what we did. So I could do it with something that's not based on money. I could say last year, 50 people came to my party. Good Lord, today's not a good writing day for me. Today, yeah, shut up. This year, of course, 7 people came. What's the percent change or the relative change? So be careful, don't say anything yet. How would I set that up? So what's the new value?
7.
7 minus the original value divided by the original value. So how much did it change by divided by where did I start? So I started at 50 last year and I want to see how I got to where I am this year. So let me do that up here. So of course, what do you get when you do that? 7 minus 50. So what is that? That's a nice one to make into a percentage, right? Because you make the bottom 100.
$86.
And what's in the negative here just means that it was a decrease, right? It was 50, now it's 7. So obviously I'm going to get a decrease by some amount. So it went down by 86%, right? Thank you, coronavirus. Okay. So this is the main formula for most of the stuff in this section.
Yeah,
Yes.
I like how you put that 2 there and made that 100. So that's a
Yes.
quick shortcut too, huh?
Never forget that. I mean, the only time you have to put this in the calculator is if the bottom doesn't become 100 easy. Because percent means out of 100, yeah. I like it.
Wow. That's
So it's really awesome when this number is 50, you just double what you get, and that's the percentage. That's the answer.
Wow.
Yeah, it's kind of nice. So let's see, last thing. If there was a house that sold for $450,000 10 years ago, and now they sold it for $380,000 now, what was the relative change? Don't say anything. Try to do this problem. What's the relative change? So you could either, so let me give you a couple of options. Because believe it or not, I'm not the biggest advocate of too many formulas in my life, which is a weird thing to hear a math person say, but there are more math people that think the way I do. Is this going to be negative or positive, this change?
Negative.
Negative. So all I care about then, I already know the answer is going to be negative. I don't need that shit. So how much did it change by? Just purely, how much did it change by?
70,000.
70,000. I like it. Divided by what? What's going to go on the bottom? Somebody else. What goes on the bottom? Who said what?
450,000.
Yeah, so it's always based on the original, where it started. And I know the answer is going to be negative because it's a decrease. I can see that it's a decrease, right? So whatever this is, 14 over 9, 1.4 over 9, I don't know. So 1 point. 14 over 9, 1.4 over 9. Oh, 1.4 over 9, so it'll be 0.1555. Somebody save me from. Is that right?
Yes.
Yeah.
Dude.
Continuous slides.
About negative 15.6%. If I want to round, I would hopefully somebody would tell you where to round it to so you don't go insane writing it all out. So there's a couple things there that the formula will always work. You can always just use it. Sometimes it doesn't, if I can see it changed by 70,000, 70 divided by 450 is that. I'm going to put a negative because it decreased. So I can see if it's a decrease. I know that if it's a decrease. Okay. All right, maybe. So this one might be a little nicer than what we've been working on recently because you can sink your teeth into this a little more. It's a little more like you can control it better. You got a formula that things have to go into. Maybe it's going to be a little less vague than what we were doing before this. Is my hope. All right. I think that's enough for today. Let me know if you want to hang out, if you got any questions. Otherwise, we are officially done for today. So you can add out if you want to. Anybody need help with
Hey,
something?
Jeff,
Yes.
back to your COVID statistics, right? I couldn't happen to think or just imagine, wouldn't it be smart to, based off the tested positive for COVID on race and see how many individuals per race are walking around maybe with the
So anytime there's a new contagion, that would be part of what they analyze is because sometimes certain things affect certain demographics differently, certain groups differently. Like, if you have a certain condition, then you're going to be more affected by this thing. And race could be one thing that they kind of break it down into. Why not? More of the time, they're concerned about how differently is treatment for people based on socioeconomic status, race, all these kind of things, right? So that's something they want to keep an eye on so that it's not too big of a disparity. But yeah, that's the medical thing about, I don't know if COVID, I've heard certain things, but I don't think I've seen anything definitive as to whether or not it's affecting certain groups more than others. It tends to be more affecting certain situations more than others. Does that make sense? Like certain living conditions or neighborhoods or things like that.
okay.
But I mean, yeah, of course they would want to do that because it's good to know. There could be something that affects one race more than another or something like that. We already have certain diseases that do that.
All right, Jeff. Thank you. Thank you for today. You have a good day.
Yeah.
See you tomorrow.
No problem. How's everybody else out there? You guys all right?
I was gonna see if we could do a problem like question 2 on the prep skills, page 227.
Oops. Let's see. Oh, all right. So that sounds so much harder than it really is. That's the one about the area of the building, right?
Yes.
Okay. So you basically, if you just make it into pure shapes, you have 3 rectangles and they're all 12 by 18, right? So you can figure out the area of one and then you have 3 of them, right? And then you have another rectangle that's 22 by 4. So I guess maybe they're thinking about carpeting this whole place. So they want to know what the total square feet is. That's all.
Okay.
Yeah.
Got it.
It's a little weird. They should have said the area of the floors or something, but because you could have a volume of a building. They should have said area of the floors in a building. That would have made more sense because that's like I'm going to put carpet down.
And that's length times width.
Yeah.
Okay. Got it.
Yeah, exactly.
Okay.
You multiply by 3 for those, and then you have one of these, and then you figure out all the areas and add them all up. You're golden. So I think that's another example where they could have worded it better. Yeah.
I think it's just a word, and I'm like, ah.
I understand. Trust me. All right.
All right. Thank you.
You're welcome. See you.
Bye.